Hello, today we're going to be talking about Docker and Drupal for doing local Drupal development. So hi, I'm David Snowpeck. I am a maintainer, co-maintainer of 20 plus projects on Drupal.org. I'm a member of the Drupal security team. I'm the co-organizer of the Drupal 414 meetup group in Milwaukee, Wisconsin. I actually gave this same presentation there last week, Thursday. If you're ever in the area, definitely stop by. We have the best food at any meetup. The other co-organizer, Steve, makes home-cooked food for every meetup. It's amazing. I'm also co-founder of myDropWizard, a Drupal support and maintenance company. We don't build sites, we just support and maintain sites that are live, and we do it at a fixed monthly fee as opposed to billing for hours. And my most important role in life, I am Tata to my two beautiful daughters, Sasha and Ava. So today we're going to be talking about development environments, by which we mean, the way that you run a web server, PHP, and the database to do Drupal development locally. Some people do development remotely, where they have like another site on the live server, or maybe like they're pushing directly to the Pantheon dev environment to do development. But today we're talking specifically about doing local development. So that's development on your laptop, desktop, computer. So in a video presentation, this is sort of difficult to do. When we did it live, we did kind of a survey, raising hands, people shouting out what they used for their local Drupal development environment. If you'd like, please, leave a comment below this video for what you use personally or what you've used in the past and your experience with those things. Some common options are WAMP, MAMP, Aquadev Desktop, Vagrant, or Docker already. So, Docker, why should I care? And to answer that question, first we're going to talk about a little bit of history with regard to local development environments. So the classic local development environment is running Apache, MySQL, PHP on your local machine on your normal OS. So just installing those packages and running them. Like we said, some examples are LAMP, WAMP, MAMP, XAMPP, or Aquadev Desktop. But why do classic development environments kind of suck? So you're stuck with whatever your OS supports. Let's say you're doing a project that's PHP 7.1, but there is no PHP 7.1 package for the version of your OS. You can't use that. Or the other way around, maybe there's some really old package because you're working on a really old production environment that no longer is possible to get running on your desktop OS. You can only generally have one of each type of thing without lots of additional work. For example, what if you have two projects and one uses MySQL and one uses MariaDB, and for whatever reason, in the context of those two projects, that difference is important, or Nginx and Apache, or several different PHP versions for different projects. Frequently, Linux will, depending on your distro, give you maybe two PHP versions, like PHP 5.5 and 5.6, or 5.6 and 7.1 or something. But if you need to go beyond that, that can get quite difficult. And while you're doing the setup of your local development environment, of course, you're messing with stuff on your host OS that you depend on to read email and do life. And you can break stuff there. And this development environment is not transferable to other people or computers. Like, let's say you have a team, you've just set up the perfect development environment. You can't really give it to your teammate. They would have to sit down and do the setup on their computer, which maybe is a different OS or a different version of the OS, so they can't do it exactly the same. Or if you get a new laptop, you might spend a day or two or three getting your development environment reset up. So virtual machines then became a common way to do development environments. I still use virtual machines for a number of projects, and they solve all of those problems. You get a whole separate OS that you can do anything you want with, install whatever software you need. You don't have to worry about breaking anything. You can have as many VMs that you need. You could have one per project. So you could have a VM for that MariaDB project and a different VM for that MySQL project. And you can share or transfer them to other computers. It's kind of a pain because the files are so big and they take a lot of time to export or import, but you can export a VM as a .ova file and put it on a USB stick and give it to your friend, and they can import, and it works, right? It can allow simulating the production environment. Let's say the production environment is a single VPS with whatever software installed. You can set up your VM with all the same software installed, configured the same way. Some examples, our Drupal VM. It's a project by Jeff Geerling. It's actually based on Vagrant to set up a VM to do Drupal development, or just using raw Vagrant or Parallels or VirtualBox or VMware or whatever. So why do virtual machines suck? First of all, they take whole indivisible blocks of disk and memory. So you say this VM gets 2 gigs of RAM and 20 gigs of disk, and even if inside the VM it's only using 500 megs of RAM and 1 gig of disk, like all of that is reserved for the VM. Unless you have 64 gigs of RAM, like I do, you can really only run 1 or 2 VMs at a time. And because VMs take so long to shut down and start up, like if you're constantly shutting down and starting up VMs, which can take 5 minutes or 10 minutes or something, like that's definitely a pain. It's nice to be able to run some long-running migrate process on one project while you're hacking on something else for another project. Maintaining a VM is just like maintaining a real server and all of the pain that comes with that. So then enter tools like Ansible or Salt or Puppet or Chef to try and make maintaining real servers easier. You end up using them on your virtual machine, and while those tools are great and definitely help with maintaining real servers or VMs, they're complicated and end up being a whole project in and of themselves. And so running VMs are generally slower than running them directly on your host system. So you've got this great new laptop, but you're only able to use a fraction of its performance because you have all that extra overhead of using a VM. So containers like Docker to the rescue. Containers run on your host machine within a separate namespace. So processes, network interfaces, routes, a bunch of different resources can be namespaced. And a process in a container can't see resources in other namespaces. It thinks the things in its namespace are the only things that exist. A container runs in its own root file system. So this is some directory on your computer which contains all the files that that container sees as its root file system. So the container can have a totally different Linux OS than your host system. So maybe your host system's Red Hat and you have a container running Debian or something like that. But there's only one kernel and no virtualization or emulation. So check out this fun graph that I made, or not graph, a chart, drawing, something? I don't know. A virtual machine, you have the host kernel on the bottom, and on top of it run normal processes. So that's just business as usual. But there's one special process, the hypervisor, and that's your Parallels or VirtualBox or VMware, which can boot another kernel and translate any requests that that kernel might make to the normal hardware and turn them into something that makes sense to the host kernel. So it's like emulating a separate computer. And then on top of that kernel run your VM processes. So you have all of these extra layers between the actual PHP that's running your Drupal site to the host kernel. And of course there's fun performance issues with files too, because it's not just accessing files directly on your host system, it's making a fake block device, which then it's creating a whole separate file system inside of, and that's definitely slow. Containers, on the other hand, you have the host kernel, which runs normal processes, and container processes, which are just normal processes with a separate namespace. Like it's just a separate field on the process in the kernel that says this process is in a separate namespace. And so those processes will compete with normal processes for RAM or CPU just like any other normal processes would, and they access files on the host system directly. They just get, here's a directory, you mount it into the container, and it accesses it directly. There's no emulation or virtualization or anything in between. So, like we just discussed, containers run on your host machine within a separate namespace, and they use the RAM or disk that they use. There's no block reserved for them, but limits can be applied. So you can say, this process should only ever use up to 2 gigs of RAM, or setting the time slices on the CPU that it should get. So they are super, super fast because of those things. And because they are fast, you can run lots and lots and lots of them. And they're easier to manage than a real server. And we'll talk about this more later, but creating an image for Docker via Docker file is a whole lot easier than creating a configuration to manage a server with Salt or Ansible or Chef or whatever. So why do containers suck? Because everything sucks just a little bit. There's new concepts. Fewer people have a deep understanding of containers, as do VMs and just normal server management. It's new technology. Docker iterates super duper fast. There's frequent bugs, breaks, new best practices that you need to learn. Something that was best practice 3 months ago might be deprecated, and there's a whole new thing you need to learn how to do, just because the technology is moving that quickly. And Docker is big. I'm not going to go into this too deeply, but Docker is a big package of basically like everything you need to have like a container solution that's useful. It's kind of the antithesis of the Unix philosophy, where you have lots of small things that work together to do a big job. Like, it's a big monolithic thing that includes a lot of stuff. Like, it has image building, it has running containers, it has a daemon that manages all the containers running on a system, that has the ability to run many of those daemons across several systems and have a swarm of containers and all this stuff. There are alternatives. Rocket is a slimmer alternative that just runs containers, doesn't do all the other things, with the idea that per the Unix philosophy, all of the other things that need to be done to create something Docker-like would be separate utilities that join together. Anyway, just a sort of point of interest, if you will. So next we're going to talk about some Docker concepts. So first of all, each container runs a single process. In a Drupal context, that would mean, for example, you'd have a container for Apache, Nginx, whatever your web server is, a container for PHP, and a container for MySQL, MariaDB, whatever your database is. And then you'd wire them together to make a complete application. There are several advantages of this one process per container model. So each container can potentially run a different distro. You can have your PHP container running Red Hat and your Nginx container running CentOS, whatever the person who created the container thinks is the easiest distro with which to create that container, they can use. It really doesn't matter that you have an application composed of several different distros. So in practice, my favorite distro is Debian, so any containers I create are going to be built on Debian, but I don't really have any qualms using someone else's container built on CentOS or whatever. If it's a useful container, it's kind of its own self-contained thing for just that process, and I can use it, even though they're using different distros. You can update them separately. You can, just replace the PHP piece, and actually, because they are separate containers, you can do some clever rolling update stuff. You could put the new PHP container in and connect it to the load balancer to the web server, and before removing the other one, and then once they're both in there working, remove the old one, so you can do updates with zero downtime and clever stuff like that. Docker will gather logs and set restart policy for each container independently, and Docker can manage networks, links, and ports, and all of that stuff for each container. So you get these extra management tools from Docker over each of these processes, over each of these containers. And it drastically simplifies the creation of images. We'll talk about this more in a little bit, but this is one of the reasons that creating a Docker file is easier than managing a whole server or doing Ansible or or Chef or any of that kind of stuff. So what's an image? A container is started from an image, and an image is basically a binary package containing the root file system for that container and some metadata. So here's some example images. These are links to the Docker Hub, where people can share their Docker images, and there's a couple official Docker images that are either maintained by the Docker team or the maintainers of the project itself. So these are links to two official images, and all images have these two parts. So this is Debian : Jessie. That's saying the Debian image at the Jessie variant. So there's a couple of different versions of Debian that you can use, and this is requesting specifically Debian Jessie. Those are actually called tags. And then here's the MySQL : latest. So it's MySQL at the latest tag. All images have a latest tag and potentially some version-based ones, so you can grab specific versions or variants of that image. The metadata for the image includes things like what process to run and as what user. And also, where are the volumes on that image? Volumes are directories that store persistent data. Images and containers are essentially read-only. Containers aren't actually read-only unless you tell them to be read-only. You can write to them in directories that aren't volumes. But if you ever want to update the image that the container is based on, you'll lose everything that isn't in a volume. So you say, this particular directory is a volume, and then that directory will outlive the life of the container. So, for example, with MySQL, you'd put the MySQL data into a volume so that when you update that container or, tear it down or whatever, you don't lose all of your database data. And a bunch of other stuff in the metadata that we're not going to talk about right now. So it's demo time. Let's start a container from an image. So we're going to run this command first, and let's dissect it a little bit. It's docker run, then this --rm, which means as soon as this container exits, delete it. So we're just going to run this container one time, and then it'll self-destruct. And this -i is for interactive, and this t is for terminal. So -it is what you put on there when you want to run an interactive terminal for the process that you're running, for the container that you're running. And we're going to run the Debian : Jessie container. So let me switch over to my terminal. I'm going to do docker run --rm -it Debian Jessie. And bam. This new command prompt comes up, and we are now inside a completely fresh installation of Debian Jessie. And we can start doing, whatever sort of things you would want to do to a Debian Jessie container, such as install some packages. I picked a weird example because this one depends on the internet and runs slow. But let's say we want to install Cowsay. Some of the examples use Cowsay. We've got our fresh Debian Jessie installation, install some packages, and start doing some things, such as have a giant ANSI art cow say things. Hopefully that'll be ready in a second. Okay, Cowsay, hello. And that did not work for some reason. A win for live demos everywhere. Did I not install Cowsay? Wow. How could such a simple demo go wrong? Oh, I bet it's because we are root and it got installed to user bin? No. Let's just pretend that that worked. That's a horrible way to do a live demo, to say pretend that my random choice of thing to do worked. But we could install, let's install PHP. That'll take a little bit longer. And is maybe a more realistic example. PHP 5, that's the name of the package. But I guess the main thing to point out is that, the starting a fresh container based on this Debbie and Jesse image took like 2 seconds. There wasn't an install process because the image is an already installed Debbie and Jesse. There's a whole bunch of really clever optimizations going on that Docker does. It doesn't actually copy, a new copy of the image. It's using a layered file system. So like all the images based on Debbie and Jesse just sort of add layers to this image that never gets modified. So you're able to start containers like that lightning fast and destroy them also super, super fast. So here, now we have PHP. We can run some PHP code and say hello from PHP. And that worked. That demo worked. So we're going to exit this terminal. And now that container has been completely destroyed. No longer exists. So all that stuff we installed, that went into a separate layer. And then we exited. It deleted the container. It deleted that layer. System's completely clean. And all of that was super, super fast. So what's next? Ooh, we're going to do a more complicated one. We are going to run a container with MySQL in it. Let's look at the command really quick. So we're going to do docker run and then -d, which says to run it as a daemon. So it's kind of the opposite of the -it we did before. It's going to run it in the background. This -p is mapping ports. So we're going to say we want to map the 999 port on our local system to the 3306, the standard MySQL port, inside of the container. We're going to give this container a name so that it's easier for us to manage later. I'm going to call it MySQL-Drupal 4.4 because I gave this presentation at Drupal 4.4. And we're going to do -e to set an environment variable. The meaning of this environment variable is defined by the image. The main way that you configure an image or tell it something is through environment variables. So this MySQL image has a script that runs, that ultimately starts MySQL, but before it starts MySQL, it looks at these environment variables and does some stuff. So we're setting this MySQL_allow_empty_password environment variable to 1, and what that means, specific to this image, I found that in the docs for the image, is that we want to create the root user with an empty password, which is something you should never do in production, but it makes the demo much easier. And then at the end here, we have MySQL:\latest. So we're asking for the latest version of MySQL. So let's run that. I'm going to copy and paste it so I don't have to try and type that whole thing. Why do you keep scrolling the whole slide? Copy this. Oops. Clear our terminal. Get a fresh start. All right, so we're going to run that command. What comes out is this hash that represents the container. That's the container's ID. We're going to do docker ps so we can see what containers are running. I apparently left some stuff I intended to stop before doing this presentation so that this screen would be completely clean. I'll just quick stop them right now. You'll get to learn an extra Docker command because I made this mistake. Okay, so we do docker ps. We can see our, this here's the first bunch of characters for our container ID. You can abbreviate them if there are no collisions, kind of like with git commit hashes. It's the MySQL latest container command. We don't really need to worry about that. Here's that port mapping that we set up from port 99 to 3306, and here's the name of the container. We are going to ask Docker for the logs for our MySQL Drupal 4.4 container. And here is the most recent output from the logs, and we can see down at the bottom that it has successfully started MySQL. It takes about 10 seconds for the MySQL container to actually start up to a point where you can connect to it. And then we are going to connect to it with the MySQL client. I'll just copy and paste that command. So yeah, we're connecting as root to the local host at port 9999. You'll see that I don't give a password. That's because the root user has no password. And we connect. We can see what databases there are. It'll just be the defaults. We can create a new database, start using that database, create some tables, whatever you want to do. And for completeness, because I always like to clean up after myself, we are going to stop and then remove the container. I always feel like with Docker, if I don't remove things right away, I'll forget that I had created that container because they're so easy to create. And then at some point I'll run out of this disk space and it'll be like, oh, what are all these huge leftover containers and images that I had running? So we are going to run docker stop, the name of our container, and docker rm, name of our container. And there we go. It has been stopped, removed, like it never existed. Let's get back to our presentation. So yeah, I hope if you had never played with Docker, you were just a little bit amazed. It's fast. It's crazy fast. Like, you know, we had a fresh Debian Jessie installation to play with in 2 seconds. We had a, you know, completely fresh MySQL database running in 10 seconds. You could very quickly create a whole bunch of new containers. If you wanted to run like 10 MySQL servers at 10 totally random versions, you could do it in like 10 seconds, right? So, you know, management of the containers, starting them, stopping them, looking at the list, seeing what the logs are is relatively easy, right? So we were able to do a bunch of pretty sophisticated stuff really fast and easily. So one last thing, while we're on the kind of Docker concepts topic, the Docker file. So images are built from a Docker file. Docker file is essentially a sequential list of commands to run. Images inherit from other images. So for example, the PHP 5.5-FPM image, that's to run PHP 5.5 as a fast CGI server, so if you're building a web app, it inherits from Debian Jessie. So it's basically like all of the steps to build Debian Jessie run, and then all of the steps to build the PHP 5.6 FPM container run. But each command in a Docker file creates a new layer to the image, which is a really clever optimization. So if a previous layer doesn't change, it just takes it from the cache. Because all of the layers exist, they all have like hash-based IDs. So iterating on your Docker file, like making some changes to some of the lines at the end, is relatively quick. You can mess around and change things and you know, experiment with your new image quite speedily. It's very developer friendly. So let's do an example. We are going to make a Docker file customizing the PHP, it says container, the PHP image. If I'm going to be pedantic, it's the PHP image. Anyway, so the first line of every Docker file is this from line. And we're going to say our new image is from the PHP 5.6 FPM image. We're going to say run, which is really the most common Docker file command. We're going to run this docker php ext install script. And this is a script that comes from the PHP image. It's a helper script to install extra extensions. Basically, the PHP image installs PHP from source, and it does it with the minimum set of extensions installed. And so then when you're making a real PHP app, you'll extend that image and run this docker php ext install script with a list of extensions that you want to install for your image. So you end up with only the extensions that you actually need. And in this example, we're installing the PDO and PDO MySQL extensions so that we could connect to a MySQL database, and the zip extension because we need to open zip files for some reason. Then we're going to copy our custom PHP ini file, which would be stored in the same directory as the Docker file, to this user local etc php inside of the container. And that location and this script and all of that stuff is things that you would see in the documentation for this PHP image, you know, with instructions on how to customize it. So I think that's all the lines, yeah. But basically, that's all it takes to customize an image. It's super, super easy. If you can run commands in the shell to do stuff, you can make a Docker file. So Docker files rock for a number of reasons. It's way easier than doing Salt, Ansible, Chef, whatever. And one of the main reasons for that is that the state and update problem don't exist in a Docker file. And what I mean by that is that Puppet or Chef or whatever looks at the current state of your system, looks at the desired state that's in your Ansible playbook, your Puppet configuration or whatever, and attempts to get you there, right? And well, how it chooses to get you there and whether it's going to work or not depends a lot on that current state. There's things that could happen to the system either on purpose or on accident or whatever that makes running that Ansible playbook do something totally unexpected, because you're trying to get it from a unknown, untested state to the desired state, and that's a really complex problem, which in a Docker file doesn't exist, because Docker files are always built sequentially. The previous state is always known. You're never really updating an image, or updating a container. You're replacing the image that the container is using. So there isn't really an update ever occurring. There's a replace, right? Which, yeah, I guess is what I was just talking about. The images and containers, except for volumes, are essentially read-only. You update a container by rebuilding on a new image, and images are always constructed sequentially and only ever concern a single process. So the other thing that makes doing like Salt and Ansible and Chef and whatever really complicated is that they are setting up the whole system with lots of different processes and all the dependencies between those processes. And in a Docker file, you're just saying, how can I get my PHP process going? And it's laser focused. So it's super easy to set up the configuration for just that one thing. Simple. So, how do we do Docker in Drupal? Or how do we do Drupal in Docker? I don't know who's inside of who, but how do we Drupal our Docker? Next, we're going to talk about Docker Compose. So earlier, we talked about how a Docker app is composed of multiple containers wired together. Docker Compose is a tool to help you do that. It allows you to write a YAML file that describes all of the services that make up your application, how they're connected, and then manage that whole thing as a unit. So generally, you put a docker compose.yaml at the root of your project. So for Drupal, that could be at the Drupal root, or maybe if you keep your Drupal code in like a doc root or something, it could be that directory above your doc root. But whatever would be like the top of your Git repo is generally where you put the docker compose.yaml file. And we're going to look at an example docker compose.yaml using the images from woadb docker for Drupal, which is one of the many, at this point, many sets of Docker images created specifically for doing Drupal. So we're going to cover this in 3 pages, looking at each of the services inside of the Docker Compose file. But first, every Docker Compose file starts with a version. That's the version of the Compose file. For some reason, my example uses version 2. Version 3 is out. It exists. And this just tells Docker Compose, what syntax for this Docker Compose.yaml should it use. We're doing version 2. And then the next section, which is the most important section, is all of the services, that's containers that make up your application. So the first one we're going to look at is this MariaDB service. And by putting MariaDB here, that's the name of the container. We want it to come from this image, this woadb MariaDB 10.1-2.1.0. They use kind of long version numbers in these woadb images, but the 10.1 is the version of MariaDB, and then this 2.1.0, that's like the version of the woadb image, like they version all of their images, in case you were wondering what all those random numbers were. So then we set some environment variables. We set the MySQL root password to the very secure password. We set what initial database we want created, a Drupal database with a user called Drupal who has access to it, and the password for that user will be Drupal. So that's the whole declaration for the database. The next service we're going to look at is the PHP container. We'll use this image wodb slash Drupal dash PHP. Actually, something I forgot to mention earlier, image names, for the official images, they don't have this author slash image name. They're just like straight image name, like PHP. But because this isn't an official image, it's not created by the PHP project or the Docker team, it first starts with wodb. So that's the author, wodb slash Drupal-PHP, and this is PHP 7.1 in the 2.1.0 version of wodb. We say that the PHP image depends on the MariaDB image. So this does two things. It says the MariaDB image has to start before the PHP image starts, or the MariaDB container has to start before the PHP container starts. And it also sets up a link from the PHP container to the MariaDB container, so it can communicate with it over this private network that Docker will create for our app. We're going to declare some volumes. So this says the // directory, which we're imagining that we're putting our Docker file, our Docker compose.yaml file, at the root of our Drupal code base. So like we download Drupal 8, and we put a docker-compose.yaml right in the top level directory. So we're going to say we're going to mount the current directory, that's what this / is, to be the /var /www/html directory inside of the container. And this is doing a bind mount. It's not syncing the files or anything clever like that. It's actually making it so the current directory is bind mounted inside the container directory, and accessing those files is exactly the same as accessing any local files. There's no syncing, no delay, no emulation, none of that junk. So that's how we're telling PHP how to get access to our Drupal files. Yeah. The next container the next service is the Nginx container. Let's talk slow enough to get my terminology correct, which is based on this wodb Drupal Nginx image. And it depends on the PHP container, because it's going to be proxying fastCGI to PHP to actually execute the Drupal code. We're going to map some ports. We're going to say port 8080 on our local machine is mapped to port 80 inside the Nginx image, so we'll be accessing our site locally on this port 8080. And we're going to set some environment variables. Again, these environment variables are defined by the image. I don't really know what these all mean, because I didn't read the docs for the Nginx image. I just copied this stuff from the wodb documentation. So I don't know what this one does. I guess we're setting a log level to debug. This one I know what it does. It is very important. We're saying we want Nginx to use the PHP container as the backend host. So this is telling it what to fastCGI connect to. And we can say it's PHP because within this Docker Compose project, any containers that are linked can access each other by name. Docker will add something to the hosts file so that they can do that. And we're going to say the server root is this /var /ww/html, same as we did for the PHP container. And then we're going to mount the Drupal files at that directory so that Nginx can access them. So that is our whole Docker Compose file. Now let's run it. So I have over here, as soon as it decides to get big, cool, a Drupal 8 code base with a docker compose.yaml in it, which is the exact content that we just walked through on my slides. It almost fits on one screen. We're like one line short of the whole thing fitting on one screen. It may have seemed like a lot when we were going through the slides, but it's actually a really simple Docker Compose file. And now we are going to execute it. So we're going to run docker-compose up-d. That says to bring everything up, as daemons running in the background. And it does its work. All of our containers have been created. Now let's try to access it in the web browser. So that would be localhost 8080. And here we go. Here's the Drupal 8.3.2 installer. We're going to go through the installer manually. In normal development, I would probably do the installation via Drush, but we're going to do it manually so that we get to see all of the parts. And of course, I have to copy the settings file. Go back to the installer. Try again. Cool. So then we put in the database credentials. Our database name is Drupal. Our database user is Drupal. Our database password is Drupal. And we go to advanced options to set what is the host, and the host is MariaDB, because like I said earlier, Docker will set up a entry in the hosts file for each of the linked containers. So this PHP container is linked to the MariaDB container, and so it has an entry in the hosts file for the name of the container. We'll save and continue. And now it's installing Drupal. Drupal form for Docker. What do you need? Email address, sure. And there we go. We have a fresh Drupal 8 installation inside of Docker. I guess more important than the fresh Drupal 8 installation is that is a fresh set of MySQL containers, a completely fresh MySQL server, right? Completely fresh Nginx container, a completely fresh PHP 7.1 container that we spun up super quickly and installed a Drupal 8 site inside of. What else do I want to show? Apparently I have the presentation open twice. Close that one. Oh, Docker Compose PS. So earlier we did Docker PS. If you do Docker Compose PS, it shows basically the same information, but only for the containers within your Docker Compose project. So you can see our MariaDB, Nginx, PHP container, the running, the port mappings. Yes, we went and looked at the site. You can stop it with Docker Compose stop. It just stops those particular services. And if we want to destroy it, because we're totally done with the development environment, I'm going to add a couple extra. Doubt there's any orphans, but we'll do remove orphans to be safe. Docker Compose down will delete those containers, and the -v will also additionally delete the volumes. And remove orphans is, I don't know, I don't want to explain it right now. It's possible to end up with containers that belong to your Docker Compose project but no longer have an entry in the Docker Compose YAML. And so remove orphans is to say to destroy them too. I'm used to typing this command when I want to get rid of everything. So yeah, that's how you would set up a Drupal app with Docker Compose. So how do we actually do it at myDropWizard? So at myDropWizard we do support maintenance for an enormous number of sites. So our problems are maybe a little different than someone who's doing just a single Drupal site that's all they work on. But I'll show you a little bit about how we do Docker for our Drupal. So all that stuff was super easy. But things start to get hard. One of the main things is managing that Docker Compose YAML file. That can really become a pain. If you take a look at the full woadb Docker for Drupal template, basically the way woadb Docker for Drupal works is they have, and it will load eventually, there we go, they have this template for a Docker Compose docker-compose.yaml file, and you're supposed to put it in your Drupal project and then modify it to your needs, and they have a whole ton of documentation on how to do that. And if you want to learn more about how Docker works. Woadby is a great set of tools and documentation to do that. But look at how complex this is, right? So this is basically the MariaDB thing we saw earlier. PHP, they show you a whole bunch of different PHP images to choose from depending on your needs. Here's some commented out stuff to set up Xdebug. Here's a commented out thing that makes mounting directories faster on macOS. Nginx configuration. Most of this is the same, but then here's some stuff for getting Nginx to connect to the reverse proxy, because let's say you want to run multiple Docker Compose projects at once. They can't all take port 80, right? So you need to have a reverse proxy. Here's some commented out stuff to do Varnish, Redis, PHP MyAdmin, Solr, MailHog, which is a really cool app. It basically pretends to be a mail server, so your app will send mail to it and then capture it. You can go look at it. So, first of all, you don't randomly send emails to actual users from your dev site, but also you get to capture those emails and look at them for testing. Node is part of your Drupal app for some reason. Memcached. Here's the actual reverse proxy setup. So, I mean, if you want to start doing advanced Drupal things, which I think is advanced Drupal things are sort of normal Drupal things, you end up spending a lot of time crafting this Docker Compose YAML file, which could be totally fine if you're only working on one project. But at myDropWizard, we have hundreds of sites that we do support maintenance for, so we can't specially craft our Docker Compose files. We want to have some standards that we just kind of set up and use for everything. Where did my presentation go? Is it back here? Yeah. So yeah, adding Solr and Memcached, Varnish, all that stuff is complex. And also, running different local tools against your site that's now containerized is also kind of a hard problem. If you want to run Drush against that Drupal 8 site that we set up, you have to write this sort of long magical incantation Docker Compose run to actually run Drush against the site inside that container. Or if you want to run MySQL, the MySQL client against your site that's now containerized, like in the earlier example, we just exposed a port, but you're not going to expose a port for every single one of your sites. You're going to have like a big table somewhere saying like port 9734 is for this site and port 9735 is for this other site. So generally, like, you wouldn't do that in real life. So figuring out how to run like your different utilities and different tools against your site can also be kind of complex. And also, we talked momentarily about the reverse proxy that Woadby uses. Setting that up to run multiple apps at once, which is kind of required, at least for us, for anyone who's doing more than one project at a time. Although there certainly are some people who don't use a reverse proxy and they just stop one Docker app, start another Docker app, which is a totally valid thing to do because it starts up and shuts down very quickly, unlike VMs. But for us, we want to run long-running audit process or something against one site while we're also hacking on another one, or like pulling down the latest copy of the production files, or we need to work on multiple apps at once, and setting up that reverse proxy is not super hard, but it's a pain. So we created a tool that we use internally called WizDev. So it's a Symfony console app whose job is to write the Docker Compose YAML and run common Drupal tasks, such as running Drush and running MySQL, and also like add-on stuff. We have some special internal tools, but also running things like bhat, race, whatever. So here's some example commands. WizDev install, it just installs via the normal, via the Drush site install command, rather than having to go through the manual installation like we did earlier. WizDev Drush will run Drush, this -- everything after the -- gets passed directly to Drush. A sort of cool thing is that you can run WizDev from any directory inside of your project, and it'll find the root of it where the Docker Compose is and figure out how to run the commands, so you don't always have to go to the top level to run your commands. We have this cool DB import that will dump your old database, import new database. It basically just combines two drush commands, but if you had to write the Docker Compose run magic incantation to run those drush commands, that would be a pain. So this is all these little convenience functions that we add for doing our local development. Oh, and if there's anything that you need to do that WizDev doesn't do, you can add a docker-compose.override.yaml, and that will get merged into the Docker Compose YAML. And this isn't a WizDev thing, this override.yaml file. That's a Docker Compose thing. It's super common for projects to commit their Docker Compose.yaml, but then like maybe a developer wants to change some setting for running it on their machine, or to mess with stuff. So then they can create a Docker Compose.override.yaml and not commit that to the repo, and that will allow them to do their overrides. So I'm going to do a really short demo. We are going to download Drupal 7, and ooh, geez, that got small. I'm going to run this drush command. And this is just a normal drush command. This has nothing to do with our tools. This is just how you would download Drupal 7 and name it something special. We're going to name it WizDev Demo. There we go, it downloaded. We're going to go into WizDev Demo. We're going to run WizDev init, which is how you would start saying, I want to create a new environment in WizDev for this particular Drupal site. And it asks you some questions. This is sort of new functionality. The question that it's asking is stupid. It's asking, what type of site this is, basically what Drupal version you're using. It's something that it could figure out on its own, but doesn't. It will in the future. Anyway, this is a Drupal 7 site, so we'll just answer 1. And then we're going to do WizDev install, and this will generate our Docker Compose, start up all of our containers, and then run drush site install to install the site. And that will take a moment, mostly waiting for the MySQL container and then waiting for the Drupal install, which it just got to the Drupal install part. There we go, installation complete. Username admin, password admin. It's a development site, you don't need to be super paranoid about passwords. And then we're going to go find the site at wizdevdemo.local.computer. Ominous that it's taking so long to load. Okay, there we go. And now we have a fresh Drupal 7 installation with a couple fewer steps than if you were doing it manually. And then, like I said, we can run WizDev drush. We can do SQL-C. That's a fun command. It starts the MySQL client. And like I said before, too, we can go into any directory deep and run WizDev drush SQL-C or whatever, and it will still work. And basically, I'll show you a little bit under the hood. When we ran WizDev init, it created this wizdev.yaml file, which is basically where WizDev's configuration is, and all it has for this project is that it's a Drupal 7 site. And then it generated this Docker Compose, which we will look at a little bit bigger, is quite similar to the Docker Compose that we looked at using the WODB images. Some random differences. This one's version 3 instead of version 2. We use our own images. We don't have use the WODB images because we have some customizations there. What else did I want to show you? Yeah, I guess I didn't have anything super sophisticated I wanted to show you, because I'll have on here a stop, but then we can do WizDev destroy, which just destroys everything. So that was a super simple demo, but the long-term vision for WizDev, I think, is going to be a lot more interesting. Um, so something we don't have currently, but we're working on adding is a plugin system to add commands or hooks or tools. Since it's a Symfony console app, any plugin that you would add would be something that you would write in PHP Symfony type code. We're thinking about actually taking the Drupal plugin component, so that creating them would be just like creating a Drupal plugin, which would be super cool. Some ideas that we have is something like WizDev add-on add Solar, which would add entry to the WizDev.yaml that says, okay, we want to use the Solar add-on, and then it would generate a Docker Compose that includes Solar, and we could maybe have some extra commands that are available once you do that add-on to manage your Solar instance. Right now, what we're doing for Solar actually is we have like a magic snippet that we copy and paste into our Docker Compose override.yaml for doing Solar. But that's like exactly the type of thing that we hate doing. So we're going to automate that away. This is a command that actually exists, but it's useless for anyone but us, is WizDev pull. We have a tool called SciDOM that manages backups and deployments for all of our customer sites. It allows us to deal with our customers the same no matter how they're hosted, like if they're hosted on Pantheon, hosted on Acquia, hosted on some custom server that works in its own custom crazy way, that we can deploy to them and back up from them the same without having to think about it. We have, we just run this SciDOM tool to say SciDOM backup, SciDOM pull, SciDOM push. And so then we have this companion command in WizDev where we do WizDev pull and then the SciDOM name of the site, and it pulls down the latest backups of the site and code so that we can super quickly create a development environment based on one of our customer sites, which is super useful for us. I envision in the future, being able to create a pull command that could be plugged into. Like it would be really easy to have pull work for any Pantheon site, for example. But maybe we could have a plugin system where people could add their own, pull logic or something. And then, yeah, we don't have a bhat command yet. We have a magic incantation again that we copy to run bhat, but like this could be another interesting add-on thing to just do that magic incantation, automate it away, so we don't have to have these docs anymore. And then this idea of hooks, which we also haven't implemented yet, where after you would do a WizDev DB import, it would run like a bunch of drush commands or shell commands or something to get the site ready for local development in case you needed to disable something or something like that. Self-managed reverse proxy, we're in the process of refactoring WizDev from its current version that we use day to day to this version 2, which is what I was showing you in the terminal. And we don't have a self-managed proxy yet for version 2. We have one for version 1, but we have some really cool ideas for how that could be configured automatically so that you don't actually have to set it up, that just by running WizDev on a new site for the first time, it'll automatically set up and configure the reverse proxy. Also, we have this idea, not currently implemented, but that it could be plugins all the way down, kind of how Drupal is sort of modules all the way down. Like you have a node module that provides functionality that's super core to what Drupal is, but it's itself a module. So we could have all of the core WizDev commands also come from plugins. Anyway, we are planning to open source WizDev once our version 2.0 refactor is complete. It may be complete right now by the time you're watching this video. I don't know when you're watching this video. But we needed this tool for ourselves. There's a lot actually now existing tools for doing Drupal development with Docker. The one that's probably most similar to WizDev is a tool called Doxel. But none of the tools worked quite the way we needed. So we ended up creating our own thing anyway, and are going to share it with the world in case someone else finds it useful in the crowded space now of Drupal Docker development environments. Anyway, I encourage you to check it out when it's available. Thank you. That is all. If you have any questions or comments, please leave them in the comments area below the video. Look forward to hearing from you.